Hello to all of you out there in YouTube land. Welcome back to another video. This one is going to be for Sec 2 Science. It's going to be about totally new stuff. So no more, what were we doing? Rocks, minerals, soil. It's been a long time, I know. So no more of that, totally new topic. Before we get going though, just a reminder that I'm going to call this enrichment, meaning you should only really be watching this if you are passing science. If you are not passing science, it doesn't mean that you're not allowed to watch this, but it means that you should be focusing on term 1 and term 2 material if you want to boost your mark. Nothing in this video is going to count for marks. It's just important stuff for you to know moving forward in science. Okay, so as I said, totally new topic here. We're going to think a little bit about gravity. All right. If I were to ask you what gravity is, whenever I do this, students tend to tell me it's something falling. And I would agree with you. Thing is, I want to give it a bit more of a high school definition. What I want to think is actually it's going to be what I call the attraction of one mass to another. So when you drop something or if something falls, what I want you to think of is that it's kind of attracted to the earth. It's moving towards the earth. All right. So then there's this other idea of something called the universal law of gravitation. And what it's going to say is that the heavier the objects involved are, the stronger the force of gravity is going to be. All right. And that the closer these objects are together, the stronger the force of attraction is going to be. So students, when they see this, ask me, well, they say the heavier masses, well, what I'm talking about is us being attracted to the planet. All right, or an object being attracted to the planet. So we know about that force of gravity or that. But does this mean, based on this definition here, masses, are two people gravitationally attracted to each other? Is there gravity between you and another person that's standing close to you, or hopefully at least 2 meters from you? Well, yes, there is. There is a gravitational force, but it's incredibly small between two people. For this to actually be noticeable, we've got to talk about a mass being like a planet or something enormous, okay? Now, one other thing. You may notice I'm using the word force here. I haven't really used that before in class. And if I'm going to mention force, I should A, put in a Darth Vader joke, and B, I should actually tell you what this means. Well, a force in science just means that we're pushing or pulling on an object. All right. So if you are pushing a button, you're applying a force to that button. If you're jumping up and down, you're applying a force to the ground. If you are tying your shoes, you are pulling on the laces and applying a force to them. So we need to be able to measure how strong a force is. And forces are given a different unit of measurement that I haven't told you about. Can you, well, I'm going to get you to guess actually. So what I'll tell you is that the unit of measurement is named after a really famous scientist. Can you guess who? Well, oh yeah, I can't hear your guesses. I can't see you put your hands up. So I'm just going to try to guess what your guesses may have been if we were all in class right now. So, hey everybody, can you name me a really famous scientist? Pretty good guess. Very good scientist. He did actually contribute a lot to gravity, but no, he's not the one I'm thinking of. Another one, any great scientist you can think of? Truly a great scientist, but no, it's not named after him either. Oh, maybe the greatest scientist of all, but no, not named after him either. The scientist I was looking for is this guy, Isaac Newton, famous for getting hit in the head with an apple, presumably the fruit, not the computer, because computers didn't exist during his time. By the way, fun fact, or actually not so fun fact, he never did get hit in the head with an apple. You may have seen images like this or cartoons like this. You've probably heard of him, but no, he saw an apple fall and he got some ideas about gravity. But I still like this cartoon and I still plan to keep using it. So anyways, force is measured in what I'm going to call newtons, which we can shorten to just the letter N if we want. All right. And by the way, it was Isaac Newton that came up with that law of gravitation thing that I showed you a moment ago. So he said, I know my head's in the way, the greater the masses involved, the greater the pull of gravity, and that the closer the objects are together, the greater the pull of gravity. And presumably he also said, ouch, that computer hurt. Okay. Now, we are going to do a lab. Just because we're not in school doesn't mean that you shouldn't be deprived of labs. So you're going to get to try one from your own house right now. All right. So here's what I'm going to get you to do. We are going to test out gravity, and I want you to look around your house and try to find two objects that have different masses that you can easily hold in your hand. So nothing too big, nothing too heavy, just something you can eat, two things you can easily hold in your hand, ideally with different masses. For instance, here's something I was thinking of. You can do a baseball and a ping pong ball. Baseball, you can hold them both in your hand. Baseball has a bigger mass, all right? And what you're gonna do then is you are gonna drop each of them from the exact same height at the exact same time. And what I want you to think about is which of these objects is gonna hit the ground first. Now don't do it just yet, because before you do any experiment, you need to make a hypothesis, all right? Don't think that just because you're not doing a lab for real means you can get around the scientific process. No, you have to do this. So make a hypothesis as to what's going to happen. Remember, your hypothesis should always be an if and then statement. All right, so before you do this, and remember, it's going to be about which one hits the ground first. So make a hypothesis. You don't need to write it down, but just think of one. And by the way, let me tell you my hypothesis. If you drop something very heavy, fragile, or valuable, then your parents will be very, very angry. So just don't. Use proper judgment in finding your objects to drop. All right, and I will do this with you. So I'm going to try this with a textbook and a sheet of paper. So what you probably noticed, if I did correctly manage to splice in that video, is that the book hit the ground first. The book is much heavier. The paper didn't really fall very quickly. It kind of fluttered to the ground. But that was not the greatest object for me to choose. The problem is that there's a lot of air in the room right now, and the paper is so lightweight that it can kind of flutter down like a parachute on the air. So the air is slowing it down. If I were to remove all the air in the room, I would die, but also the paper would fall at the same rate as the book, okay? Pretty interesting. So I tried it again, where I put the paper directly on top of the book, so there's not as much air underneath. And sure enough, it fell at the same speed or at the same rate. Okay, and just to make it a little bit more large scale, I looked through my fridge and I found two vegetables. I found this green pepper and this squash. The squash had a mass of 952 grams according to my kitchen scale, and this one, the pepper, had a mass of 150 grams. So quite different. And then, rather than just drop it from maybe a meter, I decided I'm going to drop these off my balcony. And as you can see, they both hit the ground at the exact same time. Okay, even though one of them is much heavier than the other, they both hit the ground at the exact same time. So that's something I want you to remember. Hopefully it worked for you in your little experiment too. If it didn't, try to think about why. But what I want you to know is that in theory, everything on Earth will fall at the exact same rate. Okay? And also, if you do this, it may break your vegetables. This happened to my green pepper. It kind of ruptured, but no worries. I washed the dirt off it and it was still very good. All right, nothing went to waste. By the way, there's a reason I used a squash. Stay tuned to the end of the video to find out why. Okay, one more thing we're gonna do together with this is I wanna do a little theoretical experiment involving this little dabbing stick person here standing on the edge of the building. I'm gonna get this person to drop this ball. And we're gonna watch this in super, super slow motion. It's just a little animation. And what I'm going to do is I'm going to pause the video after every second. All right. You don't have to pause. I mean, I'm going to pause it after every second. And I'm going to ask, how quickly is the ball moving? I'm going to measure the ball's speed. Okay. Not in kilometers per hour. I'm going to measure it in meters per second. So let's try this. All right. I'm going to make a little table here just to keep track. And because this dabbing stick person has not yet let go of the ball, I'm going to say our time is 0. We have not started the experiment yet. So we are at time 0 seconds. Is the ball moving right now? No, the person's still holding it. So it's going to be a speed of 0. But now I'm going to get the person to drop the ball. Here it goes. And I'm going to pause it after 1 second. And what I want to think about now is how quickly is the ball moving? Or was it moving exactly when I paused this? Okay. Now, this is just a little animation where everything is in super slow motion. But what would happen in real life if I did this with my squash and green pepper? If I paused it after exactly 1 second, I could tell you it is falling at 10 meters per second. That's the speed. Okay, let's let it keep falling. So after 2 seconds, it's fallen a little further. It's picking up speed. Its speed now after 2 seconds is 20 meters per second. It's going to continue to pick up speed. After 3 seconds, it's going 30 meters per second. You can probably pick out a pattern here. Let's pause it again after 4 seconds. How quick do you think the ball is dropping at 4 seconds? Well, you're right. It's going to be 40 meters per second. It's going up by 10 for each second. So that, by the way, is called gravitational acceleration. The word accelerate just means something getting faster. So if you're in a car and you're driving, or your parents are driving the car, I should say, if they step on the gas and the car picks up speed, you can say they are accelerating. So gravity causes things to accelerate. You can't really see it in the video of me dropping these vegetables off my balcony, but if I showed it to you in super slow motion and paused it like this, you would see that they are gradually getting faster and faster and faster. By how much? By about 10 meters per second each second. Now in real life, by the way, it's actually closer to 9.8, but I like writing 10. It just makes the pattern a little bit easier, the math a little bit easier. Okay. By the way, I want you to remember that 10 meters per second, how it kept going up by 10. I'm going to come back to that in just a second. All right. So what I want to think about now is, or just to tell you, you can calculate how much force you would exhibit in newtons due to gravity. All right. All you have to do is take the gravity, which is that value I gave you a moment ago, the 10 over here, or 9.8 if you want to be really exact. But if you take this 10 value and you multiply it by your mass, and your mass has to be in kilograms, by the way, but if you do that, you are going to get the force associated with it. So let's just do an example. I'm going to say that on Earth, I just showed you from our little experiment with the stick person that gravity causes things to get faster at a rate of 10 meters per second each second. Okay? Let's say that you have a mass of 50 kilograms. Well, 50 times 10 is 500. So there's that 500 newtons that I was talking about. You would exhibit a force due to gravity of about 500 newtons. All right. Let's say you go to the moon. The moon is much smaller than the Earth. It has a much smaller mass than the Earth. So its actual gravitational acceleration, this thing, is going to be much smaller. If you go to the moon, it's only 1.6. Well, have you changed if you go to the moon? No. If you have a mass of 50 kilograms on Earth, you're going to have a mass of 50 kilograms on the moon. What's going to change is your force, because when I do 50 times 1.6, I get 80 newtons, way less than the force you're exhibiting on Earth. And then let's go in the other direction. If you go to Jupiter, which is the biggest planet in the solar system, the biggest mass, it's got a really, really powerful gravitational acceleration. So there, if you have a mass of 50 kilograms, 50 times 25 is 1250 newtons, much, much stronger force due to gravity. And by the way, the force due to gravity is something that we like to call weight, and it's also measured in newtons. And one of the questions that I hope I'm answering for you here is, why do your science teachers always tell you that mass and weight are not the same thing? Well, they're not. Mass is the amount of matter something has. The amount of matter never changes no matter where you go, all right? But the amount of force does. And the amount of force, the reason why these numbers are changing is because I changed the gravity. The reason people use mass and weight so interchangeably is because we tend not to leave the Earth. But hey, if you're an astronaut, which some of you may be one day, you're going to have to know that these numbers can change when you leave the planet. All right. So, in conclusion, just to wrap this up, gravity is the attraction between masses. The larger the mass, the greater the pull, and the closer the object is, the greater the pull of gravity. We also learned that everything on Earth falls at the exact same rate, 10 meters per second or 9.8 meters per second, if you want to be exact. All right. We also learned that mass is the amount of matter something has. Weight is the force caused by gravity. We finally are trying to get the difference in there. And we also learned that dropping vegetables off your balcony may damage them, but you can still eat them. No vegetables were wasted in the filming of this video. Okay, speaking of vegetables, the reason I used a squash was because in Sec 5, you get to do more complicated gravity experiments where we like to do them with even heavier things. Like instead of a squash, we take a much, much, much bigger squash and we throw it out the window of the physics class. Here's a video of it. It's really nice because the air smells like fall after that. We scraped up all that squash, by the way. We washed it and we ate it in the science department. So I can assure you that none of that went to waste as well. And again, it smelled really nice. So thank you again for watching. Please like and subscribe. I feel like a real YouTuber every time I say that. Please stay safe. Let's stay positive. Wash your hands. And thanks again. Take care.